Hi everyone, our next topic in exponents is multiplying and dividing powers. So there are two properties or rules that we will look at today, and then you will practice tonight for your work. So you don't need to worry about memorizing what these are called, more just how to apply them. So I wrote the rules out in words. I will show you it with variables and then also an example. So the first one's called product of powers, which means you can multiply powers with the same base by adding the exponents. So what that means is, if you're confused about the words, is if you had a base, right, of A is your base, to the exponent of m times the same base of A to the exponent of n, that's equal to, you keep the base that they share, which is A, and all you do is add the exponents together. So that's what that means where it says you can multiply powers with the same base. I am multiplying. This whole thing here is a power. This whole thing here is a power. So you're multiplying the same bases. And to do that, I always say keep the base, add the exponent. That's like, I don't know if that really helps you. Keep base, add the exponents. And so if that doesn't make sense to you still, let's look at it with an example. If you had 3 squared times 3 to the 4th, the bases of 3 are the same. So I keep the base of 3, and then I add my two exponents, 2 plus 4. 2 plus 4 is 6, so my answer is 3 to the power of 6. You can leave your answers like this because we want to see that you understand the properties. We're not so much looking for you to put these into your calculator and get an answer. That won't give you credit for these types of problems. So let's look at number 1. Again, we want to use our properties. So we're doing 4 to the 3rd times 4 to the 5th. Our bases are the same. It's 4, so I write down that base. And because I'm multiplying the same base, it tells me to add the exponents. So I'm adding 3 plus 5. So my answer is 4 to the power of 8, because 3 plus 5 is 8. And that's how you will leave that answer. Remember, that does not mean 4 times 8. It means 4 times itself 8 times, just as a review. Number 2, let's look at it with variables. We are multiplying the same base of x. So we keep the base of x, and then we add our exponents. And once you get used to this, you don't have to write out the 3 plus 4. You can do that in your head. But my answer would be x to the 7th. Number 3. Okay, this is a little different. Now remember, what's going on here, it's all multiplication. So I can break this up just to rewrite it for everyone. This is really 4 times y squared times 3 times y. That's what that's saying without the parentheses. So when you have a problem like this with numbers and variables, I recommend that you first multiply your numbers together. So to help people, I'm doing 4 times 3. 4 times 3, that's just regular multiplication. That's 12. Now look at your variables that are the same. You have a base of y squared and y. Remember, that second y, that's really y to the 1st. So I'm multiplying y to the 2nd times y to the 1st. I keep my base, and I add my exponent, 2 plus 1. Okay, and I'll just rewrite this whole thing. So my answer is 12, y, 2 plus 1 is 3. And to be clear, it's just y that is to the power of 3, not 12. Let's do another one similar. So again, if it helps you to rewrite this out without the parentheses, you can do it. This is saying a cubed times b squared times a squared times b to the 4th. So you take your like bases. So I need to group together and think, okay, I got a cubed and a squared. So I keep my base and I add my exponents of 3 plus 2. Then I am multiplying. How do I know I'm multiplying? Because these are all being multiplied. Now I look at my next base, b. Keep the base, add the exponents, 2 plus 4. So let's clean that up. This is a to the 5th because 3 plus 2 is 5. This is b to the 6th because 2 plus 4 is 6. There is multiplication going on in there, but remember, we're kind of, if you want to put the dot, you can. But also, when I put two variables next to each other like that, it means multiplication. Okay, next one, another example for you with numbers. So if it helps you to break it up, this is negative 3 times x squared times 5 times x. So just like number 3, multiply your numbers together. Negative 3 times 5 is negative 15. And then group together your same bases. X squared, and remember that's an x to the first. So this is x to the 2 plus 1. So my final answer is negative 15 x to the third, because 2 plus 1 is 3. And last one for this rule, it's one similar to number 4. Again, if it helps you to write it without the parentheses, this is x to the 5th times y squared times x to the 4th times y to the 6th. And then group together your like bases. So we have an x to the 5th and an x to the 4th. So that's x to the power of 5 plus 4. Now I look at my y's. So this is times y to the power of 2 plus 6. Now just add, and you're done. This is x to the 9th, because 5 plus 4 is 9, times y to the 8th, because 2 plus 6 is 8. So that is all the multiplication that we will be dealing with. And of course, what goes hand in hand with multiplication, which is division. Remember, quotient is another word for division. So this is the second rule or property that we will be practicing today. So quotient of powers, you can divide powers with the same base by subtracting the exponents. So when I have my same base of a, and this time you're dividing them, instead of adding your exponents, you take the exponent that's on top and you subtract the one on the bottom. So this time you keep the base and you subtract the exponents. An example with numbers, if you had 5 to the 7th divided by 5 to the 4th. Because you're dividing, we keep the base, and again the division tells us to subtract the exponent. So you do the one on top, 7 minus 4. 7 minus 4 is 3. My answer is 5 to the third. Some people usually ask, can you get negative exponents? The answer is yes. That's a topic we're going to cover later this week. So for right now, you should be getting all positive exponents. So let's jump into this. Number 7, we're dividing two bases that are the same. The base is 4. So I keep the base of 4, and because I am dividing, I do the top exponent of 3 minus the bottom exponent of 2. 3 minus 2 is 1, so this is 4 to the first, which is 4. Number 8, let's do it with exponents. I'm dividing the same base, so I write the base of x. I'm dividing, so I take the exponent in the top, which is 6, and I subtract the exponent in the denominator, which is 4. So 6 minus 4 is 2. My answer is x squared. Number 9. So now we're kind of upping it and changing it a little bit. So what I suggest people to do is when they have something like this is to group together the numbers. And just forget about everything else. If I just asked you what's 8 divided by 2, you're going to tell me that's 4. Okay, so I'm going to put a 4, technically 4 over 1. If you want to put the 1 down there for now, that's fine. So that's done. You've taken care of the 8 divided by 2. Now let's group together the m's. Okay, so I keep the base of of m, and then I do 4 minus 3. Okay, and then your last one is the n's. So you're going to do keep the base of n, and you're going to do 5 minus 2. Anything divided by 1 is itself, so we're left with 4 m to the power of 4 minus 3 is 1, and then for n, 5 minus 2 is 3. If you just take it very step by step and methodical, you're going to get this. Number 10, again, two different variables, so let's block them off. So we got the a's. Remember, this one here in the denominator, that's a to the first. When there isn't an exponent written, it's always 1. Just like when we write x, we know that there's a 1 in front of that. So just kind of keep that in mind. I'm going to cross that out not to confuse people later. Okay, so because I'm dividing, all right, I keep my base of a, and then I take the exponent in the top of 4, subtract the 1 in the bottom, which is 1. Now let's do the b's. Okay, So I know this is confusing, but we're multiplying them. So we're multiplying them in our answer. So it's b to the power of 3 minus 2. So let's see our final answer here. 4 minus 1 is 3, so it's a cubed b to the first, because 3 minus 2 is 1. Let's look at number 11. If it would focus, that would be wonderful. Okay, so again, we have two numbers that are being divided, so let's focus on that. If I just asked you what's negative 30 divided by 10, you're going to tell me negative 3 over 1, but I'll just write negative 3 for now. Okay, now let's do the m's. So we have m to the 5th over m cubed. So that's m to the 5 minus 3. And then our n's, remember this is an n to the first down here, so it's n to the power of 2 minus 1. So let's just clean this up. The negative 3 comes along. We have m to the second, because 5 minus 3 is 2. And then n to the first, because 2 minus 1 is 1. Last one, that was, well, second to last one. All right, the last one, kind of throwing us for a loop with the 9 and the 6. But if I asked you, what's 9 divided by 6? What does that simplify to? What goes into both? I hope you're going to tell me 3. So if I divide the 9 by 3, I'm going to get 3. And 6 divided by 3 is 2. So I now have a 3 and a 2. And you leave that. That comes along for the ride. You're done. Now look at this. You have an m to the first over m to the first. So I can go through this, but I'll also show you something else after. So I have an m to the 1 minus 1. And then my last one are the n's. Remember, that's an n to the first and the bottom. So it's n to the 4 minus 1. Okay. So the 3 stays, the 2 stays. What's 1 minus 1? That's 0. And 4 minus 1 is 3. Now, if you remember from last week, we talked about anything to the power of 0. I mentioned that in passing. Remember, anything except 0 to the power of 0 is 1. So that really goes away. And my answer is just 3n cubed all over 2. Back here, you could have avoided this m to the power of 1 minus 1 and m to the 0. If you saw m divided by m, that just cancels out to 1. Anything divided by itself is 1. That's the lesson for today. Thanks for watching.